All right, let's get this thing going. Hello, everybody. Welcome to this week's Autodesk Virtual Academy. My name is Tom Fitzgerald. I am the practice lead for the design automation team here at KETIV. With me, I have Phil Steiger. He's the practice lead of the data management team. And we are excited about what we want to be talking about today. So today, we are starting a new series called Ask the Experts, where once a month, leads like myself and Phil are going to be participating on these calls to do something, very ad hoc, kind of just open ourselves up and allow ourselves to be vulnerable to your guys' questions around whatever the particular topic might be for that specific week. So this week, we want to open up the floor, having an open conversation, allow you guys to ask questions very specific around design automation. So really, as you want, if you have specific questions around design automation, it really doesn't matter what it is, as long as it really kind of within the realm of design automation and Inventor and things along those lines, and maybe some of those best practices. Whatever questions that you guys might have, go ahead and put those into the chat. Phil is going to be fielding those calls for me this week. Maybe, next month when we do this again, maybe I'll be fielding the calls for Phil. But whatever the case might be, go ahead and ask your questions. Phil is going to then ask me what those questions are, and then I'm going to do my best to answer those and provide you the answers that you need for those particular questions. So go ahead and start shooting them our way, and we're going to do our best to give you that information. Phil, are there any questions thus far?
I already got a question.
Sweet.
Tom, is it possible, this is Jerry Burns who asked this, is it possible for a DLL or an add-in to dynamically change a sheet metal part style in an assembly? For an example, while the interface dialog box is open, could you select a different sheet metal style and then see the Inventor model update the style selection would be from a drop-down box?
I see. So while a file is open, to be able to change the sheet metal style within design automation. Yeah, actually, I think that is there is a way to do that. Now, exactly what that methodology might look like, I'm not entirely sure, but I think that's within the realm of possibility in terms of what you can do with automation. So anytime that you want to graphically change things within design automation, obviously you have to take some things into consideration of how that's going to update. If you have different UIs that might be available within your session of Inventor, and you want to interact with that UI and you want to see dynamic changes on the screen, it really kind of depends on how your automation is architected. There are things that you might want to do within iLogic where you don't see those updates right away, where you're providing inputs, and then once you have everything in there, and then you execute on those inputs, and then you start seeing those changes. Well, there's other ways where as you make changes to different fields, you're seeing those updates occur. So it really kind of depends upon your particular automation architecture. But yes, absolutely, it could be supported to do something along those lines.
He responded back. He said he found ways to dynamically change parameters, but not a sheet metal style.
Not a sheet metal style. Oh, I see what you're saying. So I know that there is some sheet metal style functionality within the Inventor API. As to where those limitations might break down, I'm not entirely sure. So that might need some further investigation, but I do believe there is a way through the Inventor API to be able to dynamically change the sheet metal style of a particular sheet metal component.
So Tom, what are the different approaches to design automation?
What are the different approaches to design automation? Well, it really comes down to, there's two, well, really, if you think about it, there might be three different ways that you could do it. But the third way is really a combination or a hybrid of approach of the two primary different approaches to automation. One way is what I think most people are very, very familiar with. And that is you take in an assembly, say you want to do a product configurator, and you want to configure a series of or a product line within your company. And what you typically do is you'll have all the different possibilities, all the different options, all kind of rolled into a single assembly. And then basically what you do is you just turn on and turn off those elements of that particular design that you don't need. So if you think about level of detail and how level of detail inside of Inventor works, where you can suppress different components and then you can set a level of detail and you can quickly toggle between those configurations. The master model, what we call the master model approach, or what I like to call an overloaded model, kind of explains exactly what's happening, where you have all the different options built into the assembly. And like I said, you're just turning on and off what you do and don't and do not need. So that's the one way, and I think that's the most popular way. But as you start getting into more and more complex assemblies, you start seeing where that methodology might break down, where that approach might break down, because you have so many different components, you're suppressing different things, and that you're still left with all this ancillary information within the assembly that you may not need. And then typically what you would do is, if once you arrive at a particular configuration, you might go and delete out those suppressed components in which you don't need. Now, like I said, that's a very common approach, but yeah, it has its strengths and it has its weaknesses. The other approach, which we call more of a generative design or generative approach, what I like to call an on-demand methodology, is where you basically start with a clean sheet, a clean slate, and you only bring in the components in which you need. And then, of course, you define how those components are related to one another, either by applying dynamic constraints, where you bring a component in and you're defining within the logic how those things get constrained together, or you simply figure out where the location needs to be within XYZ space, and you drop it in, orient it, and then you lock it into place. So you can either leverage the constraints that come naturally within Inventor, or you don't necessarily have to. It really kind of depends on your use cases, what's super important to you in terms of from a business perspective, and how you're going to use that information later on downstream. Depending on what kind of relationships you have with other systems might be a determining factor in which approach you might take. So hopefully that is very clear to whomever might have asked that question. Anything else, Phil? Any other questions?
My next question is iLogic the only method to design automation?
Oh, is iLogic the only way? Absolutely not. So iLogic, as we're all pretty familiar with, if you're using Inventor, comes out of the box. It's right there available. Whoever has Inventor has the means to develop iLogic rules and use the iLogic forms to kind of create their own automation to support, whatever those needs might be within your engineering department. But as we're familiar, Inventor has an API as well. So you could legitimately create an add-in to Inventor using Visual Studio, and then start leveraging the methods that are in the Inventor API to do something very, very similar. Now, what I found throughout the years is iLogic, even though it's out of the box and it's right there and it's perfectly available, you still have to understand a little bit about coding, about VB.NET in particular, so that way you can understand how to drive different things within the Inventor environment. So iLogic, it's right there, it's readily available. However, it's excuse me, it's very flexible in terms of what you can do. And that's really great because it allows you to do a lot of different things, a lot of different ways. But just like normal, regular Inventor when you're using Inventor. Sometimes that's great, but sometimes because it allows you to do so many different things, so many different ways, that you have a tendency of developing practices that aren't as effective as other ways. So you have better practices in order to satisfy a particular need, and maybe not so good practices, right? So you really want to understand what is the best way to leverage iLogic in order to satisfy that type of automation. And like I said, it can only do so much. Out of the box iLogic, you can only do so much before you start relying upon the Inventor API and potentially wanting to use Visual Studio to support your design automation needs. Visual Studio gives you a mechanism, a means to design custom user interfaces. If you're familiar with iLogic Forms, you understand that once again, there's a limitation there. It can only do so many things. Whereas Visual Studio, you can start from scratch. You can develop all sorts of different UIs, multiple tabs, multiple pages, multiple forms that have high level of functionality and dependencies, things that are available within Visual Studio that you can't get out of iLogic. So iLogic is one way that you can create design automation. Using Visual Studio to develop Inventor add-ins is another way that you can develop the design automation. You can do a hybrid between the two of them if you wanted to, where your Visual Studio form is driving iLogic rules. And then, of course, there's also third-party applications that are available that can facilitate and support design automation. Tacton is one of the companies that KETIV partners with that does that, where you basically purchase an add-on application to Inventor, and then you can leverage the Inventor components and assemblies that you've already created to facilitate that design automation. The nice thing about Tacton is the fact that you don't necessarily need to be a programmer in order to use it. It doesn't use VB.NET. So it has a proprietary code language that you use in order to define relationships and constraints and limitations and boundaries in terms of what your automation can and cannot do. And it does a lot of the same things that iLogic can do. You can turn on and off different components and suppress different things. And you can even use Tacton to develop drawing automation. So not just working with parts and assemblies, but if you have needs to generate 2D documentation or 2D drawings, you can use Tacton to do the same thing. So you have iLogic, you have the Inventor API using Visual Studio, so an Inventor add-in, and then you have Tacton. And some of you might be saying, well, what about VBA? I mean, VBA, you can create VBA macros inside of Inventor. And that as well is another way that you could develop your design automation. But VBA is, once again, it's kind of limited in what it can do. It can still leverage the Inventor API, but excuse me, it is an aging technology. So I'm not going to sit here and say that it's definitely going away, but there are better ways to do design automation than using VBA. That's my personal opinion. All right, Phil, anything else? Any other questions coming in from the participants on this AVA?
What kind of design automations are there?
What kinds of design automations are there? Oh, okay. So there are a number of types of design automation. And I guess what that really breaks down to is, what is it that you're trying to achieve with your design automation? What is the goals? Like in manufacturing, we're very familiar with, say, for instance, I'm a company and I create water pumps as an example, okay? Well, in manufacturing, we may have different types of water pumps, different sizes, they have different capacities and different flow rates and maybe some other limitations or other specifications involved, where we might want to use design automation to allow either sales or engineering or even customers go through the process and exercise of defining what they need. So that kind of design automation is what I consider to be essentially a product configurator, right? I want to be able to configure my products based upon input information. Okay, so that's one type of automation. The other one is automation specific to developing drawings, right? Because as we know, taking components and creating relationships, excuse me, with them inside of the context of an assembly is one thing. But then when you start talking about 2D information, laying down views and scaling them and positioning them, attaching dimensions and balloons and sketch symbols and everything else, I mean, there's other things that you have to take into consideration as opposed to working with 3D information, okay? So you have a product configurator, you have drawing automation. There's a couple other things that I like to develop as well. And another type is what I call workflow enforcement. Workflow enforcement. And I've done this with a couple of companies before where they have very, very specific use cases and they have very specific steps that they want their users to take. Step one, do this, and then step two, step three, and it's very defined and very structured. And in an effort to enforce their users to follow this workflow, we create automation around it to ensure that they only select certain things, they only place things a certain way, that's very consistent, very standardized, and it allows companies to be able to ensure that there's a level of consistency and standardization that they may not otherwise achieve. So workflow enforcement. Another one is what I call standardization. So standardization automation really comes into what I consider to be more around the data itself. And what I mean by that is when we work with models and we work with drawings inside of whatever Autodesk product you might be using, it's one thing to have geometry. It's one thing to have, 2D information, views and dimensions, but that's not everything that we have to deal with within engineering. A lot of what we have to deal with is information and data itself. And Phil, you can even attest to this, the amount of information that we create and how important that information is. If you use an Inventor, we're all familiar with I properties, right? Part numbers, stock numbers, material, mass analysis, all sorts of other information about the files themselves that may not be directly related to the geometry. So standardization automation is automation that you can create in order to ensure standardization primarily around metadata. How are different fields within iProperties filled out? So that way you have a level of consistency and standardization when you have to interact and interface with other systems, like say Autodesk Vault. If you're using Inventor and you're using Vault, we all know that as we create information, we have to fill out different properties. And then we have to upload that information into Vault. Well, depending on other systems that you might have to interact with, the information that is in Vault might need to be very, very specific. If you're working with Vault, you know that when you create properties, you have options in terms of the properties all need to be in uppercase or lowercase, or they have to be of a particular length in terms of the number of characters, or they can't exceed the number of characters, or there's a very defined list in terms of what that property value can be. So in order to facilitate or rather assist Vault in that respect, you can create automation that aligns with those standards inside of Vault to ensure the information you're putting into those properties when you're developing those parts and those models and those drawings is standard and acceptable based upon your criteria for Vault or whatever other system you might need. If you're using an ERP or if you're using an MRP, you might have other things that are necessary in order for you to define within your files, and that standardization automation might be able to support that and help along the way. So product configurator, drawing automation, workflow enforcement, and then standardization automation. So those things are the primary things that I've been working on over the last few years around automation and how we can help and support our customers to ensure that they're optimized and they're efficient and they're not overworking themselves. Because if we think about it, guys, that's all automation is it's an assistance to us, because we can do everything manually if we wanted to, but I mean, why have 20 employees to do that work when if you implement some automation, maybe you only need 12 employees or 10 employees to do that, which is very interesting, because if you think about what we're asking our employees to do, we don't want them, me personally, I don't want to hire an engineer and pay them $85,000 a year in order to input data into a spreadsheet. No, I want them to be doing engineering things. I want them to be able to apply their efforts and their energies on things that they're either most passionate about or most that really benefits the company the best way it can. If it's predictable, if it's repetitive, if it's mundane, and you can easily understand and syntax what that workflow is, those are prime opportunities for automation. And that's how you really should be dissecting your workflows and understanding how all that works in order to be able to identify where automation will fit, as opposed to saying, what can we automate? We should automate everything. Not necessarily. There are some things that absolutely positively need a human being to do. And then there's other things that don't necessarily need that. So that's where you should be looking at in terms of identifying where your automation should be. What else we got, Phil? Good question so far.
Got a question here. Is there a sort of update Inventor API documentation except the API help, which is embedded in Inventor? So basically, is there another place to get the API information? Is there a document somewhere?
So when you're saying the API information, are you talking about the object model and how everything is associated to each other, or basically other supporting information of what the API is and how it works, like some third-party stuff or some other information coming out of Autodesk?
Oh, I think just from my experience on this one, I don't know if you can find any other API documentation outside of the help and in what's embedded in Inventor. Does Autodesk have it somewhere else?
They have some of that information. Okay, so let me take that back. So everything that was in the Inventor help, they've put online. So when you go to Inventor help, it just redirects you to the online version. But really, I think that's where all of the information is. They've really made an effort over the last few years to try to really kind of focus everything towards a single source of truth. So I would say the only way that you're going to get that information is go through the help menu. Now, that doesn't necessarily mean you have to do it within Inventor itself. I mean, you could do a Google search for Inventor help, whatever your version of Inventor is. So if you're using 2022, just type in Inventor 22 help. And I tell you what, it's going to redirect you to the Autodesk page where you're going to see the Inventor help, just like you would see inside of the Inventor session itself.
Next question. Do I need to be a programmer to do design automation?
Do you need to be a programmer to do this? Well, you don't necessarily need to be a programmer. And when I say that, you don't necessarily have to go through, computer science classes in order to do design automation. It is, however, helpful to understand code writing practices and how VB, specifically VB.NET, how that language actually works, because iLogic is based upon VB.NET. So if you understand VB.NET, you'll be able to understand iLogic better. That doesn't mean that you can't use iLogic if you're not a programmer, not by any means. It just means that you may struggle a little bit in understanding why things are the way they are when you start writing code inside of the iLogic rule editor. If you want to do design automation outside of iLogic, meaning you're going to leverage Visual Studio, then yeah, I'm going to say yes, you probably should either be a programmer or have a programmer at your disposal in order to help you through that process. Really, the biggest thing that you need to be focusing on in terms of design automation, particularly if you're using Inventor, is Inventor best practices. Because, and I've been saying this for going on 13 years now, is iLogic doesn't change how Inventor works. It changes how you work Inventor. That's all. Okay. So if you can't do something in core Inventor, you cannot do it using iLogic. If you can't do something in core Inventor, you can't write a Visual Studio add-in to do something that Inventor can't do. And then, of course, the third thing, like what I was saying before, is there's also third-party applications that can facilitate design automation as well. Now, if we're talking about Tacton specifically, like I said, you don't have to be a programmer to run Tacton. It has its own proprietary code language that isn't really even code per se. It's more of calculations. This equals that, or and then whatever other mathematical calculations you might use, or dependency calculations, where you might say particular parameter values might be equal to another parameter value that drives everything. So you don't need to be a programmer to use some of these third-party applications. But if you're going to use iLogic, or if you're going to use Visual Studio to create Inventor add-ins, it's extremely helpful in order to understand programming language like VB.NET.
I have another question for you, Tom.
Yeah.
Do you think C should be used more instead of VB.NET, as Microsoft is not encouraging VB.NET for several years now?
Yeah. So C# specifically, and this is an interesting question, quite honestly. So inside of iLogic, you can define if you're going to be using C, I believe it's C# code as opposed to VB.NET code. The Inventor application itself is written in C#. C# is much more extensible, much more functional, I think, than VB.NET. Microsoft, obviously, like the question suggests, is supporting C# more so than it is VB.NET. So, I mean, if you start taking all of these things into consideration, me personally, I think it's a stronger way of achieving design automation if you're extremely familiar with it, particularly if you start thinking about where the thresholds exist between the different ways you want to do design automation. Okay, take iLogic as an example. Written in VB.NET, leverages. I mean, it's a very basic language, and I would think that those individuals that developed iLogic probably chose VB.NET simply because of its predecessor, VBA, right? So here you have a VB language already that, historically people using Inventor and doing automation are probably very familiar with. So why not naturally, leverage a better version of VB.NET in order to do iLogic? But like we're saying here, C# is definitely the better language over VB.NET in terms of what it can do. And like I said before, it's extensibility and some of the functionality. So I would think if you're going to be building Inventor add-ins, I would recommend use C#. Absolutely. Particularly within the context of Visual Studio, and because you're going to get a lot more functionality out of those design automation, those Inventor add-ins, than you would get out of just using iLogic. Obviously, if you're using a third party, that would kind of depend on what those limitations might be. I would imagine there might be some third-party applications out there supporting design automation, not just for Inventor, but maybe for some other CAD applications that by default use C# as their code language. So I would definitely lean in that direction, particularly if you're new to design automation and C# is a language you're already familiar with. By all means, I would definitely go in that direction.
A follow-up to that question. Tacton is equally as powerful as iLogic. If we stay away from iLogic or VB.NET, can Tacton give same results as one achieved with iLogic and Inventor API using Visual Studio?
It depends. So, I mean, let's unpack that a little bit. Is it as functional? Yes. Can it do the same things? Absolutely. But remember what I was saying earlier in this session here was there's different approaches to design automation. Remember what I was saying, Phil, and you may be able to recall this, but there's two different ways that you can do it, where you basically have all the information within your assembly. That's the master model approach. Now, Tacton and a lot of other third-party design automation applications, they solely rely upon the master model approach, meaning you have to have all the iterations, all the different options, all the different possibilities built into a master assembly model. And you're basically turning on and off whatever it is you do and do not need. So if that is the method you choose, your approach to your automation, then yes, the answer definitively is yes. These third-party applications are just as powerful as iLogic and Visual Studio in that regard. But if you want to do a more generative design, or what I call the on-demand approach, where you're just pulling in that information in which you need, a lot of these third-party applications can't do that. They don't understand, or they don't have that capability of being able to go out to a network drive or some other repository and grab a file and then insert it into the context of an assembly, and then dynamically create constraints or position it and orient it and things like that. Okay, so it depends on what your approach is. And then, so if you think about your approach for a second, why would I choose master model over generative, or generative over master model? And that really comes down to performance, right? If you have if you have a design where you're using the master model approach, and your master assembly is what we would consider a large model, a large assembly, typically somewhere above 2,000 components, master model typically is not the best approach, simply because you have so many different options. You have so many different files that are associated, referenced into this assembly, and you have to manage all that. Then that's where performance starts breaking down. That's where the complexity of the logic starts to become overwhelming, to the point where it's very hard to manage. It's extremely difficult to scale. And if you're doing it in iLogic and you want to debug it, wow, good luck there, because that might be a little bit of a challenge. So the master model approach has its limitations, whereas the generative approach, the generative design approach, doesn't have those constraints, because you're only bringing in the information in which you need. So then you only have to accommodate constraints and relationships and everything else to just those files. You don't have to worry about all the other iterations and all the other configurations. That knowledge is stored within the logic itself, not within the Inventor files. So that's where the breakdown is at. Is if you want to do master model approach, iLogic works very well. I mean, not to say that you can't do generative with iLogic, because you can, but really the common practice with iLogic is more of a master model approach. And what I've been seeing is these third-party applications, they too leverage the master model approach. So good, very, very good question. Very good question.
So to follow up with that, how does Tacton work with Vault API, and can it interact with Vault and do some updates in Vault as well?
So right now there's no interoperability between Tacton and Vault. However, what I have been able to understand around Tacton is the fact that because Tacton has its own language, it still relies upon the normal behavior of Core Inventor. And what I mean by that is if we have Tacton driving parameter values that then change geometry, there's nothing to suggest that those same parameters couldn't be associated to iLogic rules, okay? So Tacton could drive parameters. Parameters could then, as they become changed or edited, the values, could then trigger iLogic rules to do things that Tacton can't do itself, okay? And one of the things that iLogic rules can do, if you're savvy enough, is you can create Vault API calls using iLogic rules. So in a very roundabout way, you could use Tacton to drive Inventor to then trigger iLogic rules to then interface with Vault in order to do very rudimentary types of Vault activities. You can do things like checkout. You can do some searching. You can do some replacing from Vault. And I think you can do check-in, but there's not a whole lot more that you can do around that. So you can get information from Vault, you can add information to Vault, and you can search for information in Vault using iLogic rules. So I hope that answers your question.
To follow up to the question before you just answered about generative approach, do you have to know all the possible iterations of the generative approach?
Absolutely not. And this is why. It's because if you plan well enough ahead and you understand the long-term goals and effects of what you're trying to do with automation, you can plan in scalability. And I always encourage that whenever I approach customers and I'm working with them around their design automation projects, is you always want to take into consideration, well, how can this grow? Because you have to think, a lot of the times when customers get in companies like yourselves, guys, you get into design automation, you have an immediate need. There's this thing that you need automation for. And surprisingly, as you start engaging in these projects and you start digging into it and you start uncovering different things, you start realizing where the automation could benefit you in other ways. So what I mean by that is you always want to start with what you know, but you always want to also understand that there's things that you don't know. And hopefully that some of those things that you don't know, you're going to find out along the way. So planning for scalability is essential when you're approaching design automation projects and you start wanting to develop them. So you don't have to understand everything that you need when you want to do the generative approach. It really you have to kind of simplify everything into functions, methods, and modules, if you will. So say, for instance, you know that you're going to need to go and access information out in a repository on a network drive. So you build logic around what does it take to go and search for a file, get that file, and then insert it into my assembly. So if you had to do that with 2 files, or if you had to do that with 2,000 files, it doesn't really matter. As long as you have that functionality available in order to accomplish that task. So if you break everything down by task about what you need, I need to go find something. I need to insert it. I need to constrain it. I need to update parameters. I need to populate properties. You start breaking down these functions and these tasks. So that way, as you want to scale, it's not as much of a heavy lift. And it gives you this extensibility that you otherwise wouldn't have if you were constrained to say, this is the box I need to fit everything into. So planning for scalability does not, or means that you don't have to worry about what if later on I need to add more information. So to answer your question in a very, very long way, no, you don't have to have all your answers up front when you're doing generative type of design automation. However, planning is essential, and you do want to try to uncover as much information as you possibly can. Great question.
Next question. When using boundary representation data with Inventor API, edge face, etc., can we do that with Tacton or iLogic or Inventor API?
Okay, so Tacton, I can tell you. Oh, I'm sorry. I didn't realize.
Or is Inventor API the only way?
So Tacton cannot do that because Tacton does not leverage the Inventor API. It has its own methodologies of interacting with the Inventor models and drawings. Okay, so Tacton cannot do that. The Inventor API definitely can. So using Visual Studio to create your design automation projects to leverage the Inventor API is definitely or probably the best way to do that. However, and don't you love this? It's like there's no clear lines as to, oh, this is just iLogic, this is just Inventor API, this is just Tacton or whatever. No, there are a lot of gray areas in between, and there's a lot of overlap, guys. And that's why, I guess, that's why this isn't as cut and dry and simplified as we want it to be, right? We as engineers, we want everything to be very straightforward and clear cut. And design automation clearly is not. It's just not. So it's important, once again, to plan, leverage individuals like us to guide you through these processes, to really understand where are those gray areas, where are those overlaps. So to get back to the question, iLogic, if you think about what iLogic really is, and if you're new to iLogic, I totally understand. You go into Inventor, you have this iLogic rules editor, and you have these snippets on the left-hand side, and you think, well, this is the limits in which I can work in, you know, but that's not the case. iLogic is not just what you get in the snippets. Quite honestly, how I consider iLogic, how I look at iLogic is, iLogic to me is a window to the Inventor API, okay? It grants you access to affect and leverage the Inventor API outside of just what the snippets provide to you. So if you understand the Inventor API, you can leverage and develop your code the same way as you would develop it using Visual Studio. So this is why I'm going to go back to, you don't need to be a programmer, but it's good to have that level of knowledge, or at least have a programmer at your disposal, because whatever you do within Visual Studio, you can do in the iLogic rule editor. You can write the code exactly the same way. And any of you that are on this call and want to see examples of that, I will be more than happy to do a demonstration sometime, or provide you a little bit of information more around what that looks like. A lot of the enterprise projects that I engage with my customers that want to use iLogic, I write almost all of my iLogic code leveraging the Inventor API. So once again, to get back to the original question, iLogic, the Inventor API, developing Inventor add-ins, you can do things like that, named faces, you can get edges, you can get vertices, you can identify all sorts of geometry within your model, so that way you can do more things like put names on them and tag them. So that way, if you want to do drawing automation, you know where the start and your end of your different dimensions might be, or where you want to attach your leader to a note or a balloon. Or if you're just trying to do something within your model configuration by dynamically creating sketches and cutting or joining material together within your 3D environment, but you need to be able to select faces and edges. Absolutely. iLogic, Inventor API can do all those things. Tacton, not so much because it does not leverage the Inventor API. It's okay.
What are the biggest things to be concerned about with design automation?
What are the biggest things to be concerned about? I would say the top three things that I would say in terms of preparing yourself for design automation projects is number one, planning. Everything really hinges on your planning, because your planning is going to allow you to understand what is the scope that you're trying to work within. What are you trying to accomplish? Where are your limitations? Is it just working with 3D models? Is it working with drawings? Am I going to need a programmer? Is this something I can do myself? How is this going to impact productivity? Should I be cognizant of what sales might be doing? What kind of systems do I need to interface with? So planning is a huge part of it. The next thing beyond planning, I would say it's all about the models, because like I said before, Inventor allows you to create models all sorts of different ways. Anybody put your hands up in the air if you've ever done this, where you've opened up somebody else's model and you looked at it and you're like, what the heck was this person thinking? If you give 10 people a seat of Inventor and you tell them to develop a single model, you're going to get 10 different ways. 10 different people are going to put them together 10 different ways. So that's great. That's awesome that we have that capability. But at the same time, developing models to be used with automation, they have to be done a very, very specific way. You can't be very loosey-goosey and kind of without structure and without standardization, because automation is very structured. Automation has its own limitations. So you have to make sure that you're developing your models to be able to support and accommodate the logic that you're later on going to develop. Okay, so planning is number one. Model creation is definitely number two. And I would say your third biggest thing that you need to be aware of is naming convention. Guys, I cannot tell you how many struggles and problems I've had working on design automation projects where everything, the customer's head was in the right place, they had the right direction, they had the right mind frame, they had the right personnel, they had the right resources, they had everything that they needed, but everything broke down because they had a very, very poor naming convention. The naming convention goes a long way, because if you think about how we interact with models, particularly if your design automation approach is around the generative design, right? Where you're going to go out and you're going to find the files you need and you need to put them inside of the context of the assembly. Inventor assemblies need 2 bits of information from any component that you want to put into the model. What is it called and where is it at? So naming convention, and of course folder structure, but that's later on. Naming convention is one of the biggest things that I see break down when you're trying to do design automation projects. So planning, developing your models the right way, and having a good naming convention, because naming convention, like I said before, not actually just for files either. What are you going to name your constraints so that you can identify them? What are you going to name your parameters so you can identify them? What are you going to name your properties so you know how to manage those as well? So naming convention spans across all sorts of different elements around how you're going to develop your design automation projects. Good, great question. Anybody else?
Yeah, got another question. How to start leveraging Inventor and Vault API with Forge? Forge seems like more of a core developer tool.
Okay, so let me give you a breakdown to Forge. And I think this is where a lot of people kind of lose what Forge is really all about. So Forge is a platform that has a number of different services available to users. And these services do very specific things. And as opposed to developing an application, a cloud application, Autodesk decided, well, let's create this cloud platform, have all these services available, and then our customers can go in there and cobble them together in any way they want to satisfy some level of functionality. So when it comes to Inventor and Vault on Forge, or with Forge rather, Forge can do some pretty amazing things. But if you think about, if you focus it just on the Inventor aspect, the Forge design automation service really leverages the Inventor API. So the Inventor API is on this cloud platform. So you have all these computer processing cores available to process information rapidly, as opposed to just doing it on desktop or on a server. Okay. So when it comes to Vault on Forge, so there's no data, well, I shouldn't say that. There's no Vault data management on Forge. You have some data management. You have the data management service on Forge, but that's really placing files in repositories, fetching files from repositories, maybe updating some metadata around files on the cloud in repositories. You do have some functionality in terms of connecting your on-premise Vault to a cloud repository like BIM 360 or Fusion Teams. And then there's you can do some design automation service on Forge to kind of manipulate that information, but it's kind of limited in what you can do. And it can rapidly become very complex depending on what you're trying to achieve. So there's some very specific use cases around what you want to do on the Forge platform around Inventor and data management relative to what you want to do with your on-premise tools. So that's a real good question. If you want to follow up with me about that one, I'd be more than happy to have a more detailed conversation around the Forge platform. It is something that we at KETIV want to start focusing on a little bit more. I personally, with my background coming from Autodesk, I see the value in understanding how we work on platforms, cloud platforms more. And I can see, see in my mind in the future where working on cloud platforms is going to be much more prevalent. So we're ramping up to support you guys in your ambitions to start leveraging cloud platforms as well. So please reach out to me, whoever asked that question. I'll be more than happy to have a more detailed conversation. All right, Phil, we got 5 minutes left. Let's we'll take a couple more questions and then we'll wrap it up for the day.
This is more of a suggestion. An AVA would be really good on this for the Forge platform. I think he's talking about.
Oh yeah. Oh yeah. That's definitely, yeah. You could definitely look for something like that in the future. Like I said, we're getting ramped up. And then we will, as we get more and more information, we'll be disseminating it to you guys as well.
So I think the last question today, Tom, is what is the one thing doing design and animation should do that is typically don't do? What is the one thing everyone doing design automation should do that they typically don't do? Sorry.
Oh, okay. Well, that's so I would say I think most of the companies and individuals that I've interacted with around design automation is their mentality is design automation is solely for product configuration. And like I've said previously in this conversation, that's not the case. Don't think of design automation as just, I need to come up with a configured design. That's not the case. Like I said, you have drawing automation, which is separate from design automation for product configurators, that is. You got drawing automation, workflow enforcement, standardization. You could even create automation for content generation. I've done this before, where I was working with a company that loved iParts. Raise your hand if you love iParts, by the way. This company loved iParts so much that they tried to find every single way of using iParts. If there's two children within an iPart factory, all the way up to 2,000. So they were using iParts for everything. They were using iParts within iAssemblies. Then they would use those iAssemblies in other iAssemblies, to the point where they overuse iParts and iAssemblies. They used iParts and iAssemblies to the point that their automation came to a screeching halt. There's no productivity there whatsoever. It was very inefficient. It was very time consuming. They would make one little change and it would take them minutes upon minutes upon minutes to see some sort of result. In some instances, it was so deep in iAssemblies and iParts that computers would even crash. So when they presented this to me, I was like, okay, maybe you guys are using iParts a little bit too much. And they said, well, we have thousands of iPart factories. We can't stop using them. And I said, well, what if we could help you break those iParts out into static components? And then we could also help you with redefining or reassociating those assemblies and start creating true automation that is optimized and efficient, so we can achieve what you guys want to achieve, but not having to leverage iParts. So I created automation to help them take their iParts and break them out into fully functional, standardized, static components with all the metadata, the naming convention, architected and structured in a folder structure that accommodated what they wanted to do going forward with automation. So basically using automation to generate content, okay? And you could think about it another way too. What if I have, take that pump, that water pump example I had. What if I wanted to create some logic to create a pump configuration, and I know the smallest one is this size and the biggest one is this size, but I don't know all the different increments in between. And maybe you don't want to build out all the increments in between, but you could create automation to then create those iterations, all those different increments. If it's at a 1/2 inch increment, a 1 inch increment, whatever the case might be, you could create automation to then fulfill all those increments that you need in between the smallest and the largest, whatever your boundaries might be. So product configurator, drawing automation, workflow enforcement, content generation, and then standardization automation. So there's all sorts of different ways you can use automation to supplement your engineering workflows. So that would be the biggest thing I would say people that are approaching automation should understand is it's not just about configuring models. There's so much more you can do with design automation. All right, Phil, well, we're at the top of the hour, everybody. Thank you very much. I'm really appreciative of the participation. Those people that are contributing questions, please feel free. You could reach out to myself. You could reach out to Phil. If anybody needs our email addresses, I mean, how can we provide? You want to throw our email addresses in the chat there, Phil? If anybody wants to get a hold of us about anything that we've talked about today or any other previous AVA or any of the future AVAs, go ahead, reach out to Phil and myself. We are the practice leads, and we're the ones in touch with these folks more so than most anybody else. So thank you once again, everybody. Totally appreciate your contribution. Phil, is there anything that you want to add?
Oh, thank you, Tom. It was great today.
All right. All right, guys. Thank you very much, and we'll be seeing you on the next one.
Thanks.